Welcome to this session. Indeed, this session is about an overview of the Elastic stack, but it will be highly focused on Elasticsearch itself and Kibana. We will talk about that later. As you can hear, I'm in France. I'm French. I have this lovely French accent. So for French people, then it will be easy to understand. For the others, I don't know. We'll see. Right. I hope that everything will be okay because my Chrome connection just died with the Google Meet. So hopefully everything will be okay. We'll see. So my name is David Pilato, and I have been working at Elastic for more than 10 years now, which means that everything that I'm going to tell you today, you need to take that with a pinch of salt, because I'm totally biased now. So whatever I'm saying, please try by yourself and make your own opinion. I'm trying still to be not that unfair, but of course, working 10 years at Elastic changed a lot of things. For example, I don't know really the competition and the competitors. So if you are asking me questions about the competition, then maybe I won't be able to answer, but we'll see. About questions, by the way, you have the chat. So if you want to ask questions using the chat, then it's super easy. Otherwise, you can also speak. We will take care of that. You can ask questions anytime you want. What else? No, nothing on this slide. So at Elastic, we are building what we call the Elasticsearch platform, which is mainly based on Elasticsearch. So Elasticsearch is the heart of the stacks, and this is what we are going to focus on today. So basically, this is a place where you can send JSON documents over a REST API. And then the JSON documents are going to be stored into Elasticsearch. They are going to be indexed, and we will see what does it mean to be indexed, which means that you can search for it, whatever the size of the data set that you have. You can have petabytes of data if you wish. That's the Elastic part of Elasticsearch. It's Elastic, so it can scale out if you add multiple nodes. And you can also analyze the content, meaning that you can group the result set by some columns, for example, and this is the things that we are going to cover. So you can collect a lot of data coming from different sources. For that, we have like an integration layer, which basically consists of what we call the Elastic agent, which is used to collect data from the edge machine, like a laptop, for example, or your server, and you can activate some policies on the agent, like I want to collect, let's say, Apache HTTP server logs, for example, then I just have to activate that and everything will be collected for me. We have also a tool named Logstash. I will mention that probably during the session. So Logstash is an ETL where you can extract from a source, transform the data on the fly, enrich the data as well using other sources, and then send that to whatever destination you want. And our favorite destination is obviously Elasticsearch, but you can send that also to Amazon S3, for example, if you want to archive the data that you have just collected, whatever you want to do. On top of that, you have Kibana, and Kibana is a UI. This is like the entry point to Elasticsearch, I mean, in UI style. And we will cover that as well during the session. And on top of that, we have built some solutions. So one of the solutions is the observability solution, where you can index into Elasticsearch things coming from logs, APM, when you want to do performance monitoring and management of your application, tracing, metrics, a lot of things, even things that are happening on the client side, in the web browser, for example, and you want to understand the full session or the full transaction that happened to a user and why it is slower than usual, for example. So you can get this data out of the box with this solution. Same for security. Once you have the logs for observability, why not using the same logs for security? And instead of having to send that to another third-party system, and okay, you have all that at the same place, so it's super easy to use. As an example, for our laptops, we have the endpoints for within Elasticsearch laptops, within Elastic laptops, where we are collecting the information about what is happening on the laptop, and with that we can detect if there is any malware, which we can block. We can detect for ransomware or malicious behavior or things along those lines. So everything is built in. And of course, you can build also your own application and your own services if you wish, using all the search features that we have. With all what I'm going to introduce today, everything is available within the basic tier, which means the free version of Elasticsearch. If at some point I'm mentioning something which is part of the paid offer, I will tell you explicitly. But otherwise, all what I'm going to cover today is available in the basic or standard license. So we do have different kind of licenses. I don't know, Joanna, if you want to speak about that or tell something. Charlotte, sorry.
Yeah, no problem. Yes, just as an overview, each license includes different features. So the Platinum includes features from Gold plus additional features like machine learning. And for this point, we will review that later if you have interest on paid features, but I think it's not the point today.
Exactly. Thank you. So let's start. I'm going to basically introduce how I came to Elasticsearch and what kind of problem I had to solve. So I was working at the French Customs, and when I was there, I had to build a very simple search feature. And to explain what I'm speaking about, I'm going to take here a very simple use case where you have in the database user entity, which has two fields, name and comments. And I have here 4 users that I want to index in my system. So I have David Pilato, who is developer at Elastic, Malum Laya, who works with David at the French Customs Services, David Gajo, who is engineer at Doctolib, and David, I don't know who is this guy. And the use case I had to cover at this moment was simply just add a search bar like Google. And so let the user enter some data inside and then let the user search for that. So the very first implementation I did was super easy to understand. I just used what the user has entered. And I did this select star from user where name equal David. What does it give as a result? Do you know what it's going to give? You can answer in the chat or live if you want. You know what will be the outcome of that? No? Empty set. Yes, indeed. Empty set. Yes, because we don't have the exact value. So how can we solve that? Yeah, let's do like. So yes, indeed, this is working. Select star from user where name like %David %. So I'm taking what the user has entered, I'm wrapping that with %sign, and then I'm passing that to the method of the SQL command, and then I'm getting back my result. So all good. So then I had users who are searching for both terms, so David Pilato, so it works very well. But then I have annoying users, you know. Okay, I'm using here Pilato David. I'm searching for Pilato David. So we know that this person exists, but we don't get back the results. So what can we do here? So that's kind of easy to understand. We can split, so transform what the user has entered and try to parse the content, and then produce 2 tokens, and with those 2 tokens, compare that with the database, with the like person strategy that we saw, and obviously this is working again. So here I put the end because I want to have both terms available, but I can also put a or if I want to. But here I'm using this implementation. So we can fix that. We have two fields. This is what I said previously, comments and names. So I can search for whatever the user has entered within those two fields, within the name field and the comments field. So this is working, right? I'm searching for David and I'm getting back David Pilato, Malum Laya. That could look weird, but that's okay actually, because I have David as part of the comments, right? So it's okay. And then David Gajo and David. What is annoying me here is not the fact that I'm getting back Malum Laya, is the position of Malum Laya. Malum Laya is coming back as the second position in my list, right? And worse than that, David, I'm pretty sure that's the person I'm looking for. This one is at the last position on my list. Why this? Because I'm just getting back the result as they have been inserted. So from the first to the last one, right? But so it's working well here because I have a data set on only 4 people. So when I'm looking at the result, I'm at my page in at the result, sorry, in my page, and I can easily with my eyes see that okay, I have David at the bottom of the list, so that's okay. But imagine that you have a data set with, I don't know, millions of documents, and David is the last that has been inserted in the database. It means that you need to go through all the pages until you reach the 1 million item, and then you get back this document that you are looking for. And I'm speaking here about relevancy. To me, one of the key points of a search engine like Elasticsearch is the relevancy part. When you are searching on Google, for example, or Quant or other search engine, whatever, how many times are you going to the page number 10? Like once a year, maybe? Page number 2, maybe you are doing that once or twice a month or something like that. What you expect from the search engine is to have the most relevant information on the top of the page. Right? This is what you are looking for. And with a SQL implementation, actually, you cannot really do that. So one of the key points of Elasticsearch and other search engines is to provide relevancy and sort the result set ordered by the score that we are computing, so the relevancy. We will cover that in a moment. Okay, I have also users who are doing typos. That can happen, right? So how you can deal with that? I found a solution which is not nice at all. I'm trying to combine all the possibilities on a given term. And here I have only one term. Imagine that you do that for all the terms. So it works. It's giving back the result. But when you have very big systems and you are doing those full scan things, then it's not playing very well. I can tell you. While I was working at the French Customs, for example, I had this simple search bar, and I was managing the declaration of goods, of the importation and exportation declaration of goods. So that was the system I was working on, and I implemented this simple search bar on it. So when we were having like 200,000 declaration of goods, then my Oracle database was kind of okay. It was taking something like 5 seconds to answer a question, so that was kind of okay. But when we reached 1 million declaration of goods, then my system was so busy at searching for results, and it could take 1 minute or so, that my database was not able to inject new data inside. So that was really a nightmare. So we switched back to the equal instead of the like percent thing. And then at the end, we switched to Elasticsearch, and then everything was okay. When you are implementing a search feature, not using a search engine, but another, I would say the search feature of the database, which is not really a search to me, you end up producing ugly interfaces like this one. The problem is not the CSS here. the problem is that the user has to think about some questions first. Where did the engineer put the data in? Was that in keywords? Was that in contact name? Was that in contact email? So you have to think about it before searching. To me, it's really better to just put a simple search bar, let the user enter whatever he wants, and then maybe boost the result if we are hitting on the keywords, because this is our use case. So with a search engine, like Elasticsearch or like any others, then that's the things that you can do actually and change the behavior of the search depending on your use case. So what is a search engine? A search engine, whatever search engine you are using, is made of two different features. The first feature is the index engine. This is the place where we are indexing documents. In the rest of this presentation, when I will be speaking about documents, don't think about documents as PDF documents or OpenOffice documents, but JSON documents, where you have fields, and for each field, you have a value. It could be a text, it could be numbers, it could be geopoints, it could be many things, but let's think about text now. So for the text, for each field, we are going to parse the text. We are going to do some transformation. And I think we will cover that because I think we will have enough time to cover that during the demo, but we will see. But basically, we are going to split the text into terms, lowercase everything. And then we are going to put every single term that we found in the text in the inverted index. We are using Lucene behind the scene. And Lucene is a powerful search engine. And Elasticsearch basically expose the Lucene search engine and make it super scalable. So for each term that we have, we are indexing the term, and we are making a connection between the term and the objects where we found this term. So basically here we indexed pages. So the ID that we have in the inverted index is the ID of the page number, right? So this is how the index engine, is working. And we are doing that for every field that we have and every content. So the index is typically what you have at the end of a book, right? And when you search, the second feature of the search engine is obviously to search. But what you have to keep in mind when you are working with a search engine is that you are only going to search within the created indices, not anymore within the source. Think about it as a normal book. When you want to search within a book like this one, you are not going for, if you are searching for the term fenêtre, which means window, if you are going to search for this term, you are not going to open the book and open and go through all the pages and try to find where the term fenêtre is. No, what you are going to do is to open the index. Same in Elasticsearch, you open the index, and then you go through the index and you find the term fenêtre. And as you know, an index, the ancient people who did the first indices created that in a very smart manner, that they ordered the terms within the index. So it's super easy to find the term that you are looking for, right? Because you know it's at this letter F, and then you just have to go to fenêtre, and then that's it. That's the same in Elasticsearch. Everything is ordered, so Elasticsearch is super fast at finding the terms you are looking for. And then once you have the term, you can open the objects, you can open the pages, basically. So this is how a search engine is working. Okay, good so far? That's one of the most important slides that you are going to see today. You need to understand this one. Okay, so we are going to do a lot of demos. I updated the cluster yesterday, so let's see if everything goes okay. We'll see. So I'm going to run everything on Elastic Cloud, which is not this window. So here I have this Elastic Cloud where I'm running all my services, because this is the easiest way to run Elasticsearch, actually. So you just create a new deployment, and you have automatically the latest version available on cloud. The upgrades are super easy. You just have one click to do the upgrade. Of course, when you come from a major version like 7.17 and you want to upgrade to 8.8, you have more steps to do, but it's still easy. Automatic backups, a lot of things are available on cloud. So I have deployed already here my cluster. And when you open Kibana, you are seeing this welcome page. Actually, not this one, but another one which guides you to get some data into Elasticsearch. So this is the place where you can have access to the solution that I mentioned before, observability and security. So you have a place where you can do all that. You have a setup guide, you can do many things. One of the things you can do, if you don't have any data at hand and you want to play a bit with Elasticsearch, you can click here on try sample data. And you can have here some sample data set, for example, and you can add sample e-commerce things if you want to. I think you are in the e-commerce part, so maybe this one is interesting for you. And you can have access to many information, which can be super useful. I'm not going to do that here. You have over integration. You can do many things, like I want to, I don't know, I said Apache server, for example, I want to add the logs, and okay, there is a Apache integration, and you just have to follow the guide and deploy that on the agent and things along those lines. I'm not going to cover that today. This is not the purpose of this session, but this is basically how you do that. So here, what I want to use is DevTools. So DevTools is a super easy way to send requests to the Elasticsearch cluster without using curl, because it will be a waste of time if I'm using curl. And with that, you are getting a lot of also nice feature like auto-completion, where you are doing things with the stack. So I have the entry point of the stack, and I just have to say get slash here. And so the cluster is answering me, okay, I'm alive, I'm authenticated, I don't have to give all those credentials and things like that because I'm within Kibana already. So this is the latest version of the stack that we have. So the first thing I'm going to do, so I don't have any index existing, I'm just removing it to be sure, so I don't have anything. So what I want to introduce now is how you can send JSON document to Elasticsearch. So you have basically a CRUD interface where here I can put a document into an index name person, so that will be the index name. Underscore doc is the type, so don't bother with that. Just use underscore doc when you are asked for this. By default, it's underscore doc. It's going to be removed in the next version, I think. And here, that's the ID of my document. That was the page number, basically. But now that's the ID I want to use. And the JSON document I want to index is this one, where I have the name field, and the content I want to index is David Pilato here. Okay. So let's execute this one. So I have the answer from Elasticsearch. Okay, it's happened behind the scenes. So what happened? Elasticsearch detected that actually you want to index something into an index named person, but Elasticsearch was not aware of this index. So Elasticsearch created first a proper data structure to allow documents to come into this index named person. It's like doing a create table on the fly, right? Because I want to create some content into this table. Then Elasticsearch is looking at the content itself and it's saying, okay, you are mentioning a field named name. Okay, I was not aware that you want to have that. Apparently, you are providing a text inside, so probably you want to do full text search on it. So I'm going to create the data structure that you need for that. We'll see that it might not be the right thing to do, but by default, this is how Elasticsearch behaves. So with this, it basically do a create table with the name field in it as a text. Then the third thing that Elasticsearch is doing, it's going to parse the text. This is what I mentioned before. So it's going to basically do something similar like this. Say, okay, I have found the David term and the Pilato term, and it's going to then index those documents and connect that to the document with where the ID is David. Okay, so in my index, I will have those two entries, David and Pilato, and those are connected to the document where the ID is David, this one. And then last thing Elasticsearch is going to do is to store the JSON document that we sent as is, so we are able to retrieve it whenever we want. And to retrieve a document, you can just do a get by ID. That's it. So we can get it back. And as you can see in the underscore source field, which is a specific technical field here of Elasticsearch, we have the JSON document that we sent. Okay, nice. If I want to update the doc, I can just send the same request again and provide a new version, a new full version of the document I want to index. So here, I can see that I still have name with the same name as we saw before, and then address.city, address and yes, inner city, so address.city, that would be the name of the field, and the value is Cergy. I'm living in Cergy in France. When I'm doing that, Elasticsearch is first going to say, you are speaking about a field name address.city, but I have no idea about what it is. So apparently you want to do full text search on it. So I'm going to change the schema, automatically update the schema for you. It's like doing an alter table on the fly, okay, because I have a new field. And then the same process that we saw will happen again. We are going to parse and index the name field again and do the same thing that we did. And then for address.city field, we are going to also add an entry for this other field and say this one is connected to the David ID. Okay. And finally, it's going to store the document so we can get it back again, the new version, which is now complete. And if I want to remove the document, easy. I'm using the delete verb. And then when I want to get it back, when it's not available anymore, so I have this 404 not available. Okay, so it's super easy, right, to work with the CRUD operation of Elasticsearch. I was not doing any search yet. Okay, so now we are going to do some search. So I'm going to create some documents here. I'm going to send documents without specifying an ID. So for that, instead of using the put verb, I'm going to use the post verb. I want to post documents into the index. And those are the documents I want to post. Here, so in the comments, you have ici c'est Cergy, which stands for here we are in Cergy. I'm going to send some of them, like 10. 1, 2. So you can see here that we have an ID, and the ID is automatically generated for us. 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I have 10 documents. I'm going to create like 3 documents with this one. Ici, c'est Cergy Pontoise. That's another name for my city. 1, 2, 3. And I'm going to create 1 or 2 docs where we have ici, c'est Pontoise. Okay, so this is the dataset that we have now. So let's search within this dataset. I'm going to search for that. Okay, so yeah, I need to change something here. Don't need that actually. So here, what we can see is that we have 15 documents in my index, and by default, Elasticsearch is returning here the 10 first documents. So if you want to navigate through the result, one of the way of doing that is to change the size of the page. This is what you can typically see on e-commerce website when you want to provide more information to your user. So here I will say a size of 20, for example. So here I have my list of the 15 documents. And you can navigate using the from parameter as well. Indeed. So let's do some search. So I want to build a query. I want to match on the field comments, and I want to search for Sergi. Okay, so let's search for that. So I'm getting back 13 results. Ici c'est Sergi, ici c'est Sergi, ici c'est Sergi Pontoise. Okay, all good. We have our result set, right? While we are at it, if I'm writing something like this, it's still providing the same result as we saw previously. Why this? Because when I'm using a match query here, I'm going through the same analysis process that I mentioned before. So I'm basically going to lowercase everything, split at the space if I have any space. By default, I'm going to remove the exclamation mark and things along those lines. So it will work out of the box. Right. At the end, it's like doing that kind of operation. So I'm going to compare the inverted index with Sergi here in lowercase. This is what I have in the inverted index. Okay, so I can search also for Sergi Pontoise, why not? So I have 15 results, and by the way, if I'm searching for Pontoise Sergi, it's going to give also the same result. Okay, you remember when I was speaking about people searching for David Pilato and Pilato David, it was not working in the database. Here, out of the box, it's working. So what can we see here when we are searching for that? We can see that we have Sergi. Then we have Pontoise. And when we have Sergi Pontoise, what you can notice, even though Sergi Pontoise has been indexed not at the first position, now we have Sergi Pontoise here on the top of the list. Right? Why this? It's because of the score. We are by default ordering the result set by the score that we are computing. And here, why I do have this score is because I have the two terms. I'm searching for Sergi and Pontoise, or Pontoise, and I have the two terms. I have Sergi and Pontoise matching on this field. And basically, the score that we are seeing here is the addition of the score that we are seeing for Pontoise and the score that we are seeing for Sergi. Right? So this is the addition. So nice. We now have that on the top of the list. Cool. But you might ask why Pontoise, where we have only one term, has not the same score as Sergi. Right? Pontoise the score is 1.09, and here Sergi is 0.17. Why this? The reason is the frequency of the term Pontoise within the whole index. I did not index a lot of Pontoise. I indexed some Sergi Pontoise and I think 3 Sergi Pontoise and 2 Pontoise, which means that I have at most 5 Pontoise in my whole index. But Sergi is a really frequent term, right? I don't have it only in 2 documents where I have those ici c'est Pontoise. Otherwise, I have that very frequently in other documents. So what Elasticsearch is doing out of the box, it's reducing the presence of the terms which are not that significant, right? Because Sergi is basically in every document, it does not bring a lot of value, but Pontoise brings a lot of value. That's the reasoning behind the scene. And if I'm indexing now much more Pontoise, so let's index more Pontoise. I don't know how much. I'm searching again. I still have Sergi Pontoise on the top of the list, but now I don't have Pontoise at the second kind of result. I have Sergi, because Sergi is less frequent now than Pontoise, the term. Okay? So the default algorithm of Elasticsearch when it comes to relevancy is this one. The more terms you have, the better. The more rare term you have, the better. And also what is taken into consideration is the size of the text you are searching in. Like if you are finding the text you are looking for in a short text, it's scoring much higher than in a very big chunk of text. So for example, if you are matching in the title, it will become much more relevant than if you are matching in the body of the book, right? In the very big set of data. Okay, all good. So I'm going to remove my index person again, and I'm going to use an injector. Am I connected? Yes. So this is something that I created in Java. So what is the name? So message, yeah. So it's just a simple Java application. It's going to generate random data because I don't want to search only on 20 documents. I want to search on more documents. So it's going to generate those random data and send that into Elasticsearch. I'm going to show you what the data are about here. It's going to connect to my cluster. Yeah, I'm connected. And I'm going to generate 1 million of documents. And the sample documents that I'm generating are those ones where I have, so it's about persons. I have a name, the date of birth, the gender, the number of children, some marketing data like, okay, what are the center of interest of my person, for example, and an address where I have the country, the city, and some geolocation point as well. Okay, and I'm indexing that 10,000 by 10,000 and sending that to Elasticsearch. So let's go back to Elasticsearch and let's try to search. So I have indexed so far 280,000 documents. And if I'm refreshing again, okay, I have now that number of documents. So you can see that it's coming while I'm speaking here. And while this is coming, you can start to search for things. So let's build a query, do a match query again on the name field. As you can see, we have the auto-completion here, which is super nice. Did I remove the data set? I have a doubt on something. I think I did something bad, but we'll see. Maybe my demo will fail at some point. We'll see. Here I have I'm searching for the Joe name in the name field. So the first might take some time, but after that it will be much faster when like the cluster is a bit warm. So I have that number of documents, and we can see that here I have Joe person, which is available. Let me check something because I have a doubt about something that I did. I just need to check that. Okay, all good. No, all good. So that's okay. So I have that number of documents. Let's change the size. So here I don't want to look at the documents themselves, but only the number of documents. So it's not moving anymore. Yeah, so I have my 1 million documents, right? So it did not take a lot of time to index my 1 million document dataset. So those are simple documents. You have seen we don't have so many fields within the document, but it did not take a lot of time. Okay, I have 1 million documents, but now I want to understand what do I have behind the scene within those documents. So I can compute what we call aggregations. And let's say that I want to have the distribution of my data set by gender. I can build what we call a terms aggregation on the gender field. Let's do that. Okay, it works. So in 2 milliseconds, that's the time it took on Elasticsearch side. For my 1 million documents, I know that I have that number of women and that number of men. Right. Easy. I can ask for another aggregation. Let's add here another one. Let's call that by year. And I can build here a date histogram, for example, on the date, what was the name? Date of birth, I think. and I want to have a calendar interval. I'm going to refresh this page because I don't have the auto-completion otherwise. Yes. Mouse here. Calendar interval, and I want to have 1 year. Date of birth, yes. So let's ask for this one. So in 87 milliseconds, I know that for 1 million, my 1 million documents, by year, in 9040, I have that number of people. In 9041, that number of people, etc., until the end. So my data set stops at 2010, not included here. So I have that number of people in 2009. And then I still have the distribution by gender. But what I can do more is also to take this one and make it a sub-aggregation of the date histogram, the first one. Let me auto-ident. Okay. So what it's going to provide, running that again, 1 million documents. In 9040, I still have that number of documents, but now I have for this bucket the distribution of women and men. Okay, for all the years. And same at the end, I still have the distribution by gender. And I can do more. Let's say that here I want to add another one. I want now to have, I have the number of children, which is a numerical field. And I can compute, for example, something like the average number of children. So still 1 million documents, 9040, that number of documents. Those are the number of women, and this is the average value of children for this bucket. And you get that in real time, right? You don't have to run a batch, which is running during the night and taking a lot of CPU on your database. You can do that in real time with Elasticsearch. And of course, remember that we have a search engine, so you can still do the query that we saw before, like a match query on the name field, searching for Joe. So in 6 milliseconds, I know that I have that number of Joe. In 9040, I had 70 people who were named Joe, and I had 13 male and 4 women actually within in 9040. And the woman has 0.5 children in average. Okay, so that's, to me, one of the most powerful thing in Elasticsearch. Right? You can do that with whatever data you have. So if you have logs, metrics, like operational data, of course we are using this power, right, to compute what is the response time, the average response time over the time, and blah blah blah. So you can do whatever you want with that. The bad thing with what I have shown you now is that it's all JSON, right? And probably you don't want to give your users the dev console because it's kind of ugly. So what you can do is to use Kibana for what it has been designed initially. And you can go here to Analytics and go to Discover. So here I'm going to select the person index. So it's telling me that I have nothing. Of course, because I'm looking at the data set for over the last 15 minutes, but no one was born in the last 15 minutes because I have a data set from 1940 to 2010. So I'm going to change here the date and the view. So what you can see here, I have my 1 million documents, and I have the distribution of my documents broken per year. This is exactly what we saw with the remember the aggregation by year, right? That's the result that we are seeing here. And you can also, this is a new feature, I just discovered that recently, you can here break down by gender directly on this view. So this is the distribution per year and then per gender, right? You can visualize that here. You can select here, so you have the full version of the field here. If you look at this, so this is the document that I have. You can see that as a JSON if you want. Not super interesting, I would say. But you can select the field that you want to display. So let's say I want to display the name, the gender, country, city, number of children, and why not? No, not location. That's all. Okay, so here I have my result set, and of course I can search here. If I'm searching for Joe, okay, so this is now the distribution of my Joe broken per year and split by gender. Right? I can understand now. I can visualize the content. Not hard to do. You can save that and use that for another purpose later. What you can do as well is to go to dashboards, and create a new dashboard. And out of the box, you can just say, I want to create a new visualization on my data set. And you have this simple drag and drop thing where, okay, I want to have the distribution by gender. I want to make that a donut. Okay, easy. So this is the result of the terms aggregation that we saw previously, when we were using the dev console. I can just add this one here. Okay, it's here. And then I create a new one. Let's say per date. Why not? Broken then per gender. Okay. Save and return. Let's add a new one. So you can do whatever you want with that. Let's say per country and then per city. So here's the distribution per country, then per city. Of course, I can use another visualization like this one. Maybe it's better. Save and return. Okay. And once you have done that, you can, of course, allow doing the presentation as you want to do it. So let's do something like that and something like that. Okay. So it's easy to use the dashboard here and give some insight to your end users. Then you can save that and share that with your users. So I did already that. I'm going to remove this one, don't need this one. So here I have my persons data set. So I have built the dashboard as I just shown here. So I have my total number of person here, distribution per gender, distribution per country, per year, and then split by gender, and then what is the average numbers and things along those lines. Here, average children per city. What is that? Per country and per city. I don't know. What is this one? The number of cars per city with the children average. So you have here a value. So for people who are less interested in Paris of cars, I have that number of documents between 0 and 500, and then anyway, because I have also geopoints, I can here see and put on a map my 1 million document data set, and it's fast, right? It's the purpose of the search engine is to give you very fast answers. And then the result set. Remember the view that I saved previously? I already saved it in the past. So here I can view my result set. So now I can start to ask some questions. Joe, where are my Joe? Okay, this is the distribution of my Joe. And now I can really understand what my data set is made of. I said that I have Joe who are a woman. So I can click here. This is going to add a filter. So I'm doing like drill down, faceted navigation, if you wish. That's the same thing. And that's the number of Joe who are women. And if I'm looking at the result set, okay, that's okay. That's what I have. Let's remove Joe. Let's look at the person who are only women, but born in the 70s. So I'm going to select this range. Why not? I'm going to select a woman living in France. By the way, I added like a simple link. You can do that if you want to open a new page, which is within your own system. Then here you can just open the term and go to another page, and it's super easy. But here I want to just look at people living in France. Oh, that's nice. I have like bleu, blanc, rouge, blue, white, red flag. Yeah. That's funny. That was not expected. Here you can see that the map has been updated automatically. And I have here some people in Nantes, Cergy, and Paris. Why not? I can select for people living in Cergy. Let's apply that. Okay. So you will see that it's randomly generated. I do that in a rectangle. It's not real data. And here I can see that in this region of Cergy, I have 14 people who have this average number of children here, for example. So you can understand on the map your data set, your users, your customer, whoever, if you have the geo points, of course, in your data set. I can zoom in again. Again. So I'm living here, nearby here. Let's wait a bit. It's taking some time here because I think that Chrome and the Google Meet is stealing a lot of CPU on my laptop. But anyway, so this is the distribution here of my documents. You can see that, and so this is one document that I have here in my dataset. I can see that I have Lana Lucille here who is living here. So basically what I did here is like Mythic or Tinder. I have my dating system. And I can also like draw a shape because I want to select for people living in this area. So I'm basically doing a polygon here. Let's do that one. So now I'm going to just filter and focus on those persons, right? Okay. And I have my result set at the end. And what I can do, I can say I want to have every people in Cergy, but not specifically where I'm living. I'm not interested in those ones, so I'm going to exclude this one. I'm sorry, that was not this one. I want this one. Exclude. Oops. Indeed. And if I'm zooming again, it's slow on my laptop now. It should do the opposite. Exactly. So now I can see that I have excluded those persons. I have the people living in Cergy, but not the people who are living in my neighborhood, for example. So what you can do, what I want to express here, is that whatever the type of data that you have in Elasticsearch, you can do whatever you want. Here it's more a BI, business intelligence oriented demo, but think about operational data like logs, like metrics, like security, things about business intelligence indeed, or other use case that you might imagine. As long as you have the data in Elasticsearch, then you are good to go, right? And you don't have, again, to wait for a script to compute your data. If I'm injecting new data into Elasticsearch in the cluster now, it will be, again, fast, and it will give me back the answers. Good for that? Oh, I did not notice one of the questions. As the score is changing every time we change an index, is it possible to normalize this score in ES? There are some kind of normalization. I never used that, but I saw recently something like that. But don't think about the score like as a percentage of match. Like I'm matching 80%. The result is 80% good. You can do that with the what we call the semantic search in Elasticsearch and the vector search, which is basically available using the machine learning thing that we have, which is under the commercial license. Also, you can use that as well with the basic license, but it's less practical. But with that, you will have like a percentage of not relevancy, but of certainness, certitude. How you can say certitude in French, in English? Sorry, I don't remember. Certainty, I think that's the word. Yeah, confidence. Thank you. That's the right term. Something else I want to show you. I hope it's going to work. Let's see. So that's, imagine that I have to do a presentation to my board here. And so those are the slides. I want to present Elasticsearch here. And I have this Elastic stack that I have. I'm David, blah, blah, blah. And I have a data set with 1 million documents where I have those fields in my data set. Okay, so this is my presentation. But what I'm showing you here is that actually this data set, this presentation is connected live to Elasticsearch. I don't have to update the numbers. I don't have to copy paste into my PowerPoint or whatever. Like it's connected to the system. So what you can see here, the number here is the exact number of people that I have in Elasticsearch now. Right? If I'm updating the documents, you will see that number increasing. The first layer is broken by country. The second layer, the outside layer, is broken by gender, male and woman. On the back, you can see the distribution per year and per gender. And here and even the list of the people. Those are actual data coming from my system. Even the date. I never update the date in my slides. So the date is always updated. So I want to see people in France. Okay. So I have that number of person. And why not men? Okay, so that's the number of men. You have seen that everything has been updated here and all the information. So it's connected live. And if I go back here, I see that I have that number of documents because I have selected some filters. So we are using that internally, like on monitors. When you enter into the Elastic Office, you will see the activities, the community numbers, I don't know, the Twitter account or whatever, and this is automatically rotating from one page to another and things along those lines. In the sample demo dataset that I mentioned before, it comes with a canvas demo, which is typically this one, where you can see the number of sales, but in a more elegant way of doing those visualization. Instead of doing the dashboard that I shown before with Kibana, you can do that using Canvas. It's also available in the free version, in the free tier. And you can use that to visualize more elegantly your data set if you wish. Okay. I think that's all what I have for this demo. So I'm going back. What is the duration of the session, of course, Vincent? How much time do I have?
We were on 2 hours, I believe. I reserve more, but this was a discussion. But if it's less, it's less. There's no.
Okay.
There are no specific constraint actually.
Okay, so I have enough time to explain the analysis process. I mentioned that when you are searching for text, we are going through an analysis process, which is parsing the text before indexing the document into Elasticsearch and Lucene. So the analysis process is super important to understand. And for that, we have this super nice API named _analyze, which explains what Elasticsearch is going to do behind the scene when you want to index or search for a text like this one. So here, the quick brown fox jumps over the lazy dog. And if I'm analyzing this text using the default analyzer that we are using into Elasticsearch, this is what are the tokens that are going to be produced and what is going to be indexed into the inverted index when I'm going to index this text. So I have the quick brown fox jumps over the lazy dog. I don't have the exclamation mark. Everything has been split at the space, and we can see that we have lowercase everything. Basically, this is what the analyzer is doing. But I can specify the analyzer I want to use. For example, let's say I know that this content is going to be in English. So I can use an English analyzer for this text. And this time, the is going to be removed because it's a common word in the English language. I don't need to index that, right? Quick brown fox jumps is not jumps anymore, but it jump. Means that, okay, if I'm searching for jumps or jump, both are going to work. I think, I'm not sure, let me check. Jumping. If I'm using jumping, yes, it's producing also the same jump term. Okay, so that's important to notice. And over lazy has been changed because maybe of laziness is written differently. I don't know enough for the English language. So what is an analyzer? An analyzer is built on several things. One of the important thing is the tokenizer. This is the first step of the analyzer. This is where you are, not the first step, the second actually, but let's say it's the first one. Let's say that we are going to tokenize the content using the standard tokenizer, which is the one which is used behind the scene when you don't specify anything. The default analyzer is using the standard analyzer, the standard tokenizer. After we have the tokenizer phase, we can send every single token that we have through a filter chain where we can have multiple token filters, and we are going to cover that. So for this text, now I'm going to use a French text here. L'éléphant est rose et il trompe énormément. Whatever the meaning of this text, we don't care about this one. But I'm going to analyze this text using just the standard tokenizer for now. So the standard tokenizer is just going to produce l'éléphant like this, et rose, you can see that it's uppercase, et il trompe énormément. What does it mean? It means that if I'm searching for rose in lowercase, let me do that. I'm going to search for rose. What is it going to produce? Rose in lowercase, obviously. But what Elasticsearch is going to do is going to search for this term that I'm analyzing at search time with what I have in the inverted index. But in the inverted index, I have rose uppercase, not lowercase. So it's not going to match. It's not going to give any result. If I want it to match, I need to add here a token filter, which is the lowercase one. Okay, I want now to lowercase every character. So now I have rose in lowercase, which means that if I'm searching for rose in lowercase, it's going also to produce rose. And obviously, I'm going to find rose here, so it will match. Okay, so that's what you need to do if you want to build your own analyzer, because the default analyzer might not fit your needs. Okay. So let me add more things. Yes.
We have a question in the chat.
Okay, thank you. When we have an analyzer specify, will it also use the dark tokenizer? No, you can search whatever tokenizer you want, and I'm going to build my own analyzer here. Right? This is what I'm going to do. So if I don't want the standard tokenizer, but I don't know, the keyword, which is kind of useless, but not on this one. Oh, let's say this one. This is going to produce only one token. Okay, so you can choose the analyzer, the tokenizer you want to use in your analyzer. So here I was using the lowercase one. I'm going to cheat a bit because I don't want to copy paste everything all the time. One other thing I can do is to add a stop word token filter. And this stop word, I'm going to provide the French dictionary, which is provided by Lucene and built into Elasticsearch. So for this text, I know that I have a French content. So I just basically want to remove the text that I don't really care, like here, et il does not bring a lot of value. You know, it's a common terms, I would say. So it's going to be removed from here. Let's add a new one. If I'm searching for, well, what is it here? Oops, sorry, going back here. Where was I? I was here. If I'm searching for l'éléphant, remember this text. sorry, this one. If I'm searching for elephant, this term, it's not going to match because I have indexed l'elephant with this L and apostrophe character. So what I need to do is to provide a new token filter here. So this is something you can apply to Italian and French language. I think it's only applicable to those languages, where you can provide a list of the elision characters you want to remove. So instead of indexing now l'elephant, I'm going to index elephant. Right. But what if a user is searching for elephant? Elephant is not elephant. It's not going to work. So what can I do? I can provide here another filter, which is the ASCII folding. And what it's going to do, basically, it's going to change all the diacritics to their ASCII equivalent. So here I will have elephant now instead of elephant. And then I can use a stemmer, and the stemmer is going to provide me the radical version of the terms. So here I'm going to use the built-in Light French dictionary. And what it's going to do, for example, for trompe, this one is going to produce trompe, but only T-R-O-M-P. I think that if I'm saying trompe, oh, no, not this one. This one is working, but trompe, yeah, so this one is working. Trompe is not working. Énormément is reduced to its more simple version. Here I'm using the Light French, but I can use the French dictionary. Oh, so basically what I'm showing you here is the exact content of the French analyzer. I'm showing you that here, the French analyzer. So this text is going to be the same thing that we saw. So now you understand how the French analyzer is made of. If you want to use the French analyzer but need to modify things, you can go to the documentation, and it will basically give you all that. So this is how is made the French analyzer. Then you can just adapt it to your needs. So here, instead of using Light French, I can use French. Let's do that. And you will see that it will be a bit more destructive. So elephant is now elef. Rose it became rose. Trompe. Let's try with trompe now. Okay, it's still trompe. So you can see, to solve my problem with the past version of the verb, then if I'm using a French instead of Light French, it will work. But maybe it's going to produce bad things. So this is something you need to test and make sure that it fits to your use case. And this is not the easiest part, I would say. Okay. Okay. Let's speak about n-grams. I found that interesting as well. Sometimes you can use what we call n-grams to parse again the tokens that are produced by your analytics chain. So here, let's say that I have this term elef, and I want to use the edge n-gram filter with those settings. If I'm sending that to the analyze API, this is what is going to be produced, and so what is going to be indexed into the Elasticsearch inverted index. As you can see, I have EL, ELE, ELEP, ELEPH. What does it mean? It means that now I can start to search with tokens which starts with EL. Don't use the wildcard query. We have the wildcard query into Elasticsearch, but it will be slow, specifically if you start with a star, which is one of the worst things that you can do with Elasticsearch. If you want to kill your performance, then do that. Otherwise, if you want to provide fast answer to with Elasticsearch, use other strategies like this one, for example. And The n-gram instead of the edge n-gram is basically the same thing, but it's going to travel within the term. So EL, ELE, LE, LEP, EP, EP, EPH, PH. So it will be much faster at search time because you have indexed exactly the right term that you are searching for. But you have to pay a price. It's always a decision to make. The price will be at index time. It will take more time to index because you are going to generate much more tokens and more space on disk. Right? So choose your battle. If you want speed, then you need to trade the speed for the index time it will take and the size. If you don't care about speed, then of course you can use the wildcard query if you want. So let's see that in practice. I don't have an index. So remember I mentioned that when you are creating, when I sent the very first request during the demo, yeah, I was sending this one. I did not define anything into Elasticsearch. I said to Elasticsearch, do your best. But very often it's not what you want to do. For example, I want to deal with French content. I don't want Elasticsearch to use the standard analyzer. So I need to define things I want into Elasticsearch. I'm not forced to define everything, but I need to define at least some few things. So this is basically what I'm doing with this request. I'm creating the index first before sending the first document into the index. And what I'm saying here, I'm giving some settings for the index. Here, the number of shards and replicas. I'm not going to cover that here. But the analyzer that I want to create, remember that I was building a custom analyzer for the French. So here I'm defining my French custom analyzer that you can see here. And for auto-completion, I'm using this autocomplete token filter that I define here, and I'm using an edge n-gram here. So this is the strategy for auto-completion that I mentioned just before. And then I'm defining my mapping. I'm telling Elasticsearch that you will find a text in JSON documents, which name is description. And I want to perform full text search on it. And I want to use my French analyzer, Français analyzer. Yeah. I have a username field. I want to perform full text search on it. But at index time, I want you to use the autocomplete analyzer that I created just before, which is using the edge n-gram strategy that we saw. But at search time, I want to use another search analyzer. I'm going to explain why in a moment. So here the simple analyzer. And same goes for city. You will see some documents with the city field. What I want to do by default, I want to do full text search on that. And I want you to use the analyzer français, the French one. But at index time, I want you to generate some subfields. So instead of indexing only into a city data structure, I want you to index into a city.autocomplete data structure. So for the same text, it will be analyzed in different ways, one with the French analyzer and the other one with the autocomplete strategy that we saw. Okay. And if you search within the city.keyword, which is also generated at index time, I'm going to use the type keyword. And this type is super useful when you want to compute aggregations. You don't want to split at the space, but you want to keep the name of the city complete, I would say. And also, if you want to do sorting, to avoid having like weird results, you can just sort on a keyword data fields. So what is this thing with autocomplete and simple? Why I'm doing that? Let's say that I want to index Cergy and Senac. So those are two cities in France, right? And I'm going to use my autocomplete analyzer. When I'm running that, for Cergy, I will have CE, CER, CERG, etc. And for Senac, I will have CE, CNA, CEN, sorry, CENA, and etc. Okay, good. When I'm searching, let's say the user is entering CER. If I'm using the same analyzer that I'm using at index time, which is the default behavior of Elasticsearch, then I will go through the same autocomplete analyzer. So this is going to produce two tokens, CE and CER. And if I compare those two tokens with what I have indexed, I will see that I have CE and CER matching, but I will have also CE matching from Senac, which means that my user is entering CER, but I'm going to give him an answer which is Senac, and it's not going to be, I mean, relevant for our use case. Instead, I can define the simple analyzer, which basically doing lowercase thing only. It's going to generate this CER instead, and it's going to be compared with what I have indexed with the autocomplete analyzer here. And CER, I can find that into Sergi only, not in Senac. Then it's going to provide me the right content. Okay. I think I'm done for the demo. If you have any question, don't hesitate. Yeah, lazy is due to stemming. Yes, indeed. So we have seen many things into Elasticsearch and Kibana so far. We are providing now out of the box with the paid version, which is also available on cloud, obviously. This S-Ray Elasticsearch Relevance Engine, where you don't have to build your own model. We have built a model for you. You just have to activate that on your text, and it will help you to implement semantic search, for example, instead of searching for, I don't know, a dress which I don't know, which has this brand or whatever. You can search for connected, meaningful terms. I'm not going to cover that. That could be something that we can demo in another session with a solution architect, for example, if you are interested in this part. With the so Elastic, you can build multiple solutions, and one of the solutions that we have out of the box as well is when you want to provide a search engine within your company to search across multiple data sources. Like you have data in Jira, you have data in GitHub, you have data in Google Drive, you have data in Gmail, you have data on your file system, or you have data in Dropbox or whatever, and you want to provide a simple search bar to search across all those data sources to your organization, then it's super easy. You just have to check this out, and it's very nice to have. I mentioned the observability part. You can see here some percentage broken per, I don't know, per host. So those are aggregations. Now that I hope you understand the power of Elasticsearch, you can understand that you can apply that to whatever. And this is where it plays very well with the observability solution as well. So you can check that out. Not going to demo that today, but yeah, that's also something we can cover later. Security. So we have a SIEM, we have a XDR protection for your laptops. So there are free version of it, and there are paid version of the paid feature, I would say, within this solution. I like a lot this view, for example, and this is a demo I like to do sometime. Here is where you have an agent on your laptop, on the laptop of every single employee that you have within the company, and you want to monitor what is happening. And at some point, we saw an alert somewhere where someone pinged a nasty host. We know that this host is a bad one and probably is going to steal some of your data. And when you open the alert, you have basically this view, really this view. And here on the right, you can see that this executable has been run, and this is the one who was calling the DNS entry point that we are aware that it is nasty. And if you look back, this call has been made by this executable. which does not mean a lot of things. But we know that is executable has been generated by this certutil thing. Certutil is a way on Windows to decode base64 content. And if you look where this is it coming from, actually, this is Excel. So Excel has been able to call certutil to decode the base64 content, which produced this executable. And where this is coming from Outlook. So someone, and we have the name of the person, basically, open an email, and we know the name of the email, and open the Excel from that. So we have the full vision of what happened and why do we have this alert, for example. So this is super powerful thing. Elastic is used widely. If you are searching on Wikipedia, for example, then you are searching within Elasticsearch. So it's still an old version of Elasticsearch. But yes, you can definitely search for French, English content, Japanese content, or whatever. So we are covering that. If you are searching on Stack Overflow, you are using Elasticsearch always behind the scene, because yes, it's Elasticsearch which is powering the feature. We have people who are indexing for logs more than 10 million documents per second. Of course, you need to scale the cluster properly to do that, but those are the numbers you can do with Elastic if you need to. If you are using Uber, you are using Elasticsearch behind the scene, not only to search what is the street name, but also to find where are the drivers nearby you. So those are the things that are Uber is using. If you are searching for restaurants or things like that, something like Yelp, you can implement that easily as well. If you are using Tinder, you are using Elasticsearch behind the scene. And in France, we have also a lot of brands. Brands are using, yes, the Elastic. So the French government, a lot of entities are using, of course, Elastic. So the French custom, I said before. So banks, Mythic again is using Elasticsearch. So a lot of companies. And so you are using Elasticsearch behind the scene, but you don't know that you are using Elasticsearch all the day. So that's basically what I have for today. Yeah, so 1 hour and a half. Yeah, I think it's okay. We do have meetups, and we have meetups everywhere in the world. But for the French people who are around the table today, I'm organizing meetups, so you can check that out. We did the last meetup last week. And the guy, and the video is available on our YouTube channel, by the way. And the guy was explaining how exactly works the scoring system in Elasticsearch and Lucene. And that was super interesting to see. If you don't know how it works, all the math behind the scene, that's super nice to see. It's really something very easy to understand. It's in French, though, so sorry for the others, but I think we can find the other resource. Thank you, Charlotte, for the link. And we have the user group as well, where you can ask for any question, of course. If you have support with Elastic, of course, it's better to discuss with your support team, because on Discuss, we don't have any SLA, but at least we can answer you as well.